Welcome back to Dr. Liu's VCE Chemistry channel. Today, we'll break down the spectroscope analysis questions from the 2024 NHT Chemistry exam. My explanations might need refinement, so I welcome corrections or feedback from teachers, parents, or students. The observation of 5 peaks in the carbon-13 NMR spectrum of the pure unknown amino acid indicates the presence of 5 distinct carbon environments. While valine and aspartic acid have only 4, both proline and glutamic acid possess 5. However, proline exhibits a single peak around 180 ppm due to its sole carboxyl group, whereas glutamic acid shows 2 peaks in this region, corresponding to its 2 carboxyl groups. Thus, option B is correct. What's key about this organic compound is its non-cyclic structure, combined with the presence of a single chlorine atom and the complete absence of nitrogen. The infrared IR spectrum of the compound is shown here. A broad peak observed in the 3200 to 3600 per centimeter region is characteristic of the hydroxyl stretching vibration of an alcohol. This indicates the presence of an alcohol functional group in the compound. The base peak in a mass spectrum is the highest, most intense peak. In this case, it is at MZ45. The peaks with the highest MZ values, at 94 and 96, are likely the molecular ions. This molecule contains chlorine, which has 2 main isotopes, 35Cl and 37Cl, accounting for the 2 types of molecular ions observed. With a total relative peak area sum of 7, the compound must contain several hydrogen atoms that are a multiple of 7. 4 distinct chemical shifts confirm 4 different H environments. The relative peak areas of 3:1:2:1 indicate the proportional number of hydrogens in these environments. Specifically, the peak at 1.3 ppm, with a relative area of 3, is characteristic of a methyl group. The compound's IR spectrum shows an alcohol functional group, and its mass spectrum confirms the presence of 1 chlorine atom, but no nitrogen. In the 1H NMR, the 1.3 ppm peak, relative area 3, strongly suggests a methyl group. The peak at 3.2 ppm, relative area 1, is consistent with a hydroxyl proton. Furthermore, the 2 hydrogens at 3.5 ppm and the 1 hydrogen at 4.0 ppm are significantly deshielded, implying their carbons are bonded to either the chlorine or the hydroxyl group. Collectively, these spectral characteristics allow us to deduce 3 different plausible structures for the compound. Without the IR spectrum to confirm the presence of a hydroxyl group, we rely on the mass spectrum and to the power of 1H NMR data. The mass spectrum is a powerful tool in this case, featuring 2 molecular ion peaks at MZ94 and MZ96. These peaks are a clear signature of a chlorine atom, giving an average molar mass of 94 grams per mole. The base peak at MZ equals 45 further supports the proposed structure by suggesting the loss of a CHCl fragment. Additionally, the to the power of 1H NMR spectrum provides crucial details, showing 4 distinct hydrogen environments with a proton ratio of 3:1 to 2:1. This includes a 3H signal, which is consistent with a methyl CH3 group. In the absence of the to the power of 1H NMR spectrum, the compound structure is determined by combining the IR and mass spectrum data. The IR spectrum provides key information about the functional groups, clearly showing a hydroxyl group and a carbon-chlorine bond. This is corroborated by the mass spectrum, which confirms the presence of a chlorine atom with its characteristic 2 molecular ion peaks at m z equals 94 and m z equals 96. The mass spectrum also gives structural clues through its fragmentation pattern. A base peak at m z equals 45 suggests the loss of a CH2Cl fragment, and a peak at m z equals 15 indicates a methyl CH3 group. This section of the exam focuses on the spectroscopic analysis of various organic compounds. It is worth 11 marks, representing 9.2% of the total marks for the exam. Multiple choice question, 1 mark, question 30. Students are required to analyze a 13C NMR spectrum of a pure amino acid and identify it from a list of 4 options: Valine, Proline, glutamic acid, and aspartic acid. Short answer question, 10 marks, question 6. This question requires a comprehensive analysis of a non-cyclic organic compound. The compound contains a single chlorine atom and no nitrogen atoms. Part A. Interpret the IR spectrum to identify the presence of an alcohol functional group. Part B. Analyze the mass spectrum data, including the base peak at m Z45 and the molecular ion peaks at m Z94 and 96, to confirm the presence of chlorine isotopes. Part C. Explain the to the power of 1H NMR spectrum, noting the 4 distinct peaks, the different hydrogen environments, and the presence of a methyl group. Part D. Draw the structural formula of the compound, ensuring it is consistent with the spectral data, and confirms the presence of both an alcohol functional group and a single chlorine atom. Part E. Discuss the consistency of the proposed structure in 2 hypothetical scenarios, when the IR spectrum is unavailable. Should you require assistance, please feel free to connect via WeChat or WhatsApp and send an email. Thank you for your attention. Kindly note the details of Dr. Liu's VCE Physics, Chemistry, and Biology channels.